Hello, everyone, and welcome to number Core Dev meeting number 70. We're going to get started with the Istanbul updates related to clients. I think we can just look at Martin's table for that. There's a link both at the top of the agenda section and as a link in item number 1. I believe pretty much everything is done with, or actually, yeah, everything's done with Geth. Everything's done with Pantheon. Uh, is everything done with Trinity, Jason? Because it said merged plus issue, but I didn't look at the Blake2 or Blake F stuff.
Yeah, it's working, but it's too slow. You can DOS it by putting in too many rounds. It's not fast enough, but it's
Got it. Okay. And next we have parody. I think the Blake 2 one was the only one left for you all last I looked.
Like for us, like we are actually done everything, and for the Blake2 one, it's just because there was past discussions on the core devs, and we're just waiting for this meeting and see if there's any changes to the spec. If not, we will just press the merge button and we're done.
Wonderful. Yeah, and I think we're going to talk about the Blake2F stuff today. Who is that?
That was me, Martin. So yeah, I don't know if everyone noticed, but on the Istanbul tracker, there are added two fields at the bottom to signify if the clients have implemented Genesis activation support, and that is kind of important for in order to do testing with like, so if I can spin up parity in my own little private Istanbul, it would be very nice. So those teams who have implemented Genesis activation support, ping me and I'll add it. And also we've talked about activation delay switch, which is nice to have. Yeah, so I can update the table.
Okay, excellent. And then is there anyone here to speak on behalf of Aleth? Okay. And then Thomas for Nethermind, it looks like you're all good, right? Except for anything we changed for Blake F.
Yes, so now we're waiting for the test to be available so we can confirm if everything works as in any other clients. But yes, we have Blake implemented. We looked at the discussion around it, but generally we have it and we started optimizing it as well ahead. I think we already have it at a decent speed, but it will be much improved.
All right, excellent. Okay, so now that we've gone over kind of where everyone's at as far as the client updates, I know that Jason and Thomas and Paul and a few other people in the Gitter chat kind of wanted to address some of the possible like issues that we haven't like hammered out with the Istanbul EIPs, especially the fact that some of them haven't been merged in the repository itself. So with that, let's start with Blake 2, Blake2F, I should say. Did we kind of come to a like we have the maximum number of rounds already in there, but people are talking about reducing it just to make it, it's from my understanding, more like easier for gas consumption, I guess. Am I saying that right?
Yeah.
Okay, perfect. Yeah,
I
I
would
can
actually
talk technical this morning.
I would disagree with that statement. So I spent quite a bit of time in trying to understand Blake2 and Blake2B specifically, and the EIP. And I was confused, and maybe others were as well, because the EIP and the discussion over time use different names. So initially, okay, sorry. So initially it was called a Blake2B precompiled, then it turned into a Blake2F function, and then it turned into a Blake2BF function. And all of these terms are used interchangeably in the EIP. But it turned out that the EIP right now only focuses on Blake2B, which is a specific configuration of Blake2. And Blake2B specifies the rounds to be 12, and that's it, it's fixed. Blake2B, the configuration itself means that it's 12 rounds, it has a specific initialization vector, it has a specific set of round constants, and a specific buffer size. So that's what Blake2B is. And the EIP right now, even though specifies the F function, it uses it's an F function specific to Blake2B. So in the end, I don't see any reason to add a round argument because Blake2B has it set at 12.
Okay, Jason, I know that you wrote a little bit about this. Do you have any comments?
Yeah, so I guess there's the two things mixed up in there. Is the you know, no one seems to think that we're going to need 4 billion rounds, but there is, you know, maybe the desire to use fewer or more rounds in Zuko's words. And so there's the kind of bringing down the limit as kind of wasted bytes, so we could use less gas. But then also this question of, you know, is there actually usefulness in having the F function rather than that's flexible on rounds versus just pinning it to 12 rounds. I don't have enough familiarity with the way it's going to tie into things like Zcash and others, other than to say that the people who do have more familiarity are saying that they want this flexibility to change the number of rounds, and I'm just taking them at their word on that.
So I think the big confusion is that if you have a fully flexible F function, then you would need the number of rounds, you would need the initialization vector, and you would need a bunch of other parameters which the current EIP doesn't have. But if you want to only support Blake2B, then the EIP is fine. But if you change the rounds, then you won't have Blake2B anymore. It will be a different Blake2 configuration. So there just doesn't seem to be any reason to keep the rounds parameter if we don't introduce the other parameters to Blake2. So maybe just a background, Blake2 itself is a flexible hashing framework, and it has a configuration part, and Blake2B and Blake2S are specific configurations of the Blake2 hashing framework.
But they're also not the only two.
Well, there is Blake2B, Blake2S, and there are two parallelized versions of them. And there's Blake2X, which is a version to support variable length output. The parallelized versions are compatible, so the hash you would get from Blake2B and Blake2BP would be identical, but obviously Blake2B versus Blake2X wouldn't be identical. So if you change any of these parameters, you will get a different hash.
So I'm looking at the EIP, and as of 17 days ago, from the people who were advocating it, they seem to have reviewed it enough to say this is good to go. So it sounds like what they want is just Blake2B. Is that not accurate? Have they expressed that somewhere else that I'm not seeing, that they want more flexibility?
I can react on this specific. For instance, this is Louis from Stockware. Right now, we won't be able to use the precompile because it's way too expensive compared to KChack or other other hash function. But basically, if we could use at some point Blake2X, that would be useful for us because we don't need an output of 256, but we need an output of 180, and being able to make variation in the hash size would be useful for us in the long run.
Okay, so that flexibility is wanted. I think I want to hear what other people
sorry,
think, but at this point, oh, go ahead, Martin.
Yeah, I didn't really quite understand what Luis just said. Were you supporting the existing flexibility, or did you say that it doesn't matter?
No, it don't. I mean, right now the flexibility apparently is wrong. I'm just saying that in the ideal case that we would want to have it available, but if it's going to delay Istanbul by many months, not worth it, I would say.
Right. So what you're saying is basically, as it is right now, it is unusable, and it doesn't matter to you if we remove the rounds. The only thing it would matter, and it would improve things for you, was if we made it fully generic. That's what you're saying, right?
Exactly what I'm saying. That said, and I would want Alex's opinion on it. For instance, Blake S 2S is just as good security-wise than Blake2 2B. Would the parameters be the same for S and B today?
No, you cannot use this for Blake2S. Blake2S requires different word size and initialization vector and rand constants.
Which rand constant, I know it's 10 instead of 12, but I was thinking. I wonder if the initialization vector was something that.
No, that's different, and the current EIP is hard coded at the Blake2B initialization vectors.
So in that case, it should. I mean, if modifying it requires a long time, I guess just go for Blake2B and just change it to Blake2B. Just change the name to Blake2B and limit and specify the number of rounds. I would say. I would agree with you. That's what I'm
From
Yeah, it certainly would delay things, I think, if we were to make it more generic. Go ahead, Martin.
Now I was gonna just talk a bit from the testing perspective. So as far as I see it, modifying the input format a bit or dropping the rounds would not be a big problem for testing. We basically just need to modify the existing test vectors a bit and then regenerate the tests. However, if we add anything, such as adding, either making it more generic or making some other change where we introduce one more error condition, then we would need to actually invent some new test cases.
It would be an EIP from scratch, my understanding, and that's
right. Well, yeah, but there was some previous things that Alex said where you just add the mlen field and stuff, which is a minor modification and it does really make it more. It's not a full generalization.
I would say maybe let's just drop the round, set it at 12, call it Blake2B, because we don't support Blake2S anyway. When we were looking, so I was reading Alex's detailed report on this one, and we also noticed that when implementing that the specification transitioned into Blake2F function, but didn't provide any additional parameters to allow for different support. And then we couldn't work with the existing libraries. We had to extract it, and very strangely assume the vectors for Blake2B, but at the same time leave the flexibility of the round. So it did feel unnatural and wrong. And Alex's detailed analysis just confirms it. So and yeah, as Martin says, I also see that adding this flexibility, unless we have some very, very detailed statement from the EIP proposers on exactly how this flexibility should look, would be more difficult than just dropping the rounds and assuming it's Blake2B. Later, we can improve it into additional pre-compos or just modifying the existing one, probably more like adding a new one.
So the three uses for specifically having flexibility that I saw listed by Zuko are the Blake2P, the Blake2X, and just the ability to flexibly change things in say the Zcash protocols. And you know, he listed this. He was specifically addressing this this question of, can we get by with just Blake2B, or is it useful to have the F function separate? And it's worth noting, I guess, that you did say it would suffice for BTC relay style Zcash integration to have just Blake2B, but these other things are, more capabilities that we have by exposing that function, which means they'll want it eventually. I don't know enough to do any more really beyond relay what he said.
I think that we should just take note that that might eventually be what people want. We can't guarantee that we would ever make another pre-compile to add that flexibility. It's definitely something that we would need to see once, after Istanbul's done and once people request it for their use case. For the purposes of the meeting today, I think we've all concluded that we're just going to keep it Blake2B. Am I right?
And specifically, that means fixing it to 12 rounds.
Yes, that's my understanding.
So my understanding of the comments from Zuko is that the first comment where he mentioned the rounds and the different configurations, I think those were assuming that this is a fully generic EIP. I mean, that's how I read that comment, but I could be wrong. But the second comment he made is specifically about Blake2B itself and how that would be satisfactory for a Zcash bridge.
Great. All right. It sounds like we can keep it fixed then. What was someone saying?
I have a question. I mean, I'm going to ask harshly. Who was the champion for this EIP? Who pushed it? Because, I mean, if at this stage, if we only keep Blake2B compression function, then why just didn't we make it hash Blake2B? Because right now, like, people are going to get access to this and think like, oh, this is the hash itself, and it's not. Like, it's seems really made if we now decide it's Blake2B.
So the current EIP, even if we fix it for Blake2B, but still it's the F compression function, it still offers a certain amount of flexibility within Blake2B itself. Because Blake2B can have keying and can have personalization and can have salting. And you could implement all of those with, well, a regular Blake2B hashing function probably exposes all those features. But with this compression function, you can implement them outside. And actually, the personalization and salting is needed for the Zcash proof of work. And then other feature you can make use of is that potentially you could have a starting state of a hash, for example, a starting state where you hash like 1 megabyte of data already, and you could just hash the next 128 bytes on top of that. So that's like some kind of flexibility you have. I'm not sure if these are useful, but they are there.
Clearly could be useful. I do see cases where it would be useful in zero knowledge, to be specific, actually. So it would be useful.
Okay, great. So you were asking who, like, specifically was who was I guess championing this?
Yeah, I mean, the thing is, I mean, this, I don't know, just it felt like because all this thing should have, I think like it should have been like handled by the champion. That's the only kind of feeling I got.
Yeah, I agree with you. I think James Hancock ran a group of people that included input from like Zuko, some people from Starkware, obviously, and others. And it's unfortunate that Oh, actually, James, you're on here. I thought that you weren't on here. James, do you want to address this?
Yeah, I missed the first part of it, but as far as the Blake2B stuff in the beginning went, is so we did talk with Zuko and a bunch of the Zcash guys and got a lot of them together. We didn't have a ton of resources for implementing, so the thought was get something in that has the hash function, and then if there's any updates that need to happen, those can be done as people implement. We can figure out what those are instead of pre-optimizing for what those are, because all the stuff that has been kind of found out has been after. we have had something that someone could work with. So for me, it gives it's a good roadmap for what to do with this.
Okay. I think for the sake of time today, since we've spent a bit of time on this, let's just go with the reality that what we have is a Blake 2B EIP. It needs to be reflected as that, so the EIP does need to be better reflected as a Blake 2B EIP. The rounds need to be specified so that they can be properly implemented in a way that everyone can understand and make sure they're doing it correctly.
Okay,
Yeah,
and I'll go back to and listen to the beginning of the call, and then go back to the Keep team who's been doing development and get yes, do that.
Okay, great. Martin, did you have a comment?
yeah. Before we leave Blake, the Blake thing, so Alex had some other nitpicks, and I was wondering if that's something else we should talk about.
What do you think, Alex? Is that something we can handle in Gitter or with the Keep team through James Hancock?
Sorry, what else did I have?
So you
Just
mentioned something about the length, and you mentioned something about the T fields.
yeah. So the T fields are the offset counters, aka the bytes already pushed into the hashing function. And maybe I would just retract that proposal, because if we keep it as it is, 128 bits, you do have the opportunity to maybe hash something upfront outside of EVM and just supply that starting state. So I'm fine with leaving that as it is. It just has to be properly explained that this is 128 bits because this is Blake 2B, but we agreed to that. And the only other change proposal I had is the length field for the message, which is a gas optimization on EVM, because for the last block has to be zero padded, and in EVM, so I have implemented the proof of work from Zcash. I mean, not fully, but I have an implementation just for measuring the gas, and as part of that, I use the precompile. And that's where I ran into this issue. It's just awkward in the EVM, and it would be much easier just to supply the length, which is also the way other precompiles work. For example, the ModX EIP works in a similar fashion. But I think we can discuss this outside of the call as well.
Great. And in the chat, you can see that Matt Luongo, one of the champions of this, had some comments that can be addressed in the all core dev Gitter, just like we talked about. But James and Louise and others from the Zcash team and Starkware, great job on bringing this forward. And yeah, I think this has been a success of pushing an EIP through that has a good use case.
Actually, yeah, sorry if I'm being an asshole here, but I really think it would be good if we can get to a decision today on these things, and not draw it out and decide over Gitter.
I guess the problem is we don't have the champions with the technical I guess ability to be able to comment on what they want for their use case is my understanding. We have James in here and Louise, but not the other champions who would maybe be able to
Yeah,
comment.
I just want to comment. We didn't champion this. That's why I'm complaining, to be honest.
Oh yeah, yeah. Sorry about that. Yeah,
Basically, my point was we're complaining. I'm complaining because it feels half baked, to be fully honest.
got it. So Martin, I don't know if we have the proper people in here to do that.
Right. Yeah, the thing I just thought we just decided to drop the rounds, and I wanted to have this decide what to do about the M lane, and then I thought we could consider it done.
Yeah, I think the M length is the only thing. The rounds are decided.
The M lane.
I had James look at the lengthening, and he gave it a thumbs up on Gitter from a James press search when he looked at it. as far as the only thing I'd be concerned about is breaking the, as Matt's saying, is breaking the compatibility with the RFC. But I think Matt can figure out what
Yeah,
things
Matt.
does and doesn't.
Matt can speak on that. He's in here.
So as
Hey.
long as
Hi, Matt. James, you can just finish your statement. Feel free.
well, I was gonna say as long as things aren't gonna break the RFC, I don't think there'll probably will be a problem putting in some of those smaller things that make sense.
Yeah, I don't think we're not trying to hold back anything that's just going to make this easier for the EVM or make the function signature better from like a gas perspective or anything like that. We just don't want to, for example, fix the rounds and kill any future use cases that we don't know about.
Matt, I have the RFC open right now at section 3.2, which is compression function F is the title. And the function itself only has 4 parameters: age, which is the state, M, which is the message, T, which is the offset counter, and F, which is the finalization flag. It doesn't have the rounds as an input.
That's fair enough. One sec, I'm getting Piotr to pop in as well and going through the PR to make sure that I don't miss my own rationale and misreport. But because F is not an export function, I'm less concerned about matching the F function signature, and I'm more concerned about matching what F actually accomplishes. So.
I'm not sure.
Give me half a sec to catch up with you, Alex.
Yeah, I'm not sure what's the best way to resolve the confusion, because yeah, we have taken up quite a bit of time.
Yeah, that's kind of why I was expecting this to potentially go offline, because we know that they're in the Gitter chat, and this can just be a back and forth in there and easily be resolved as not on this call.
Yeah, I don't know if you guys do parking lots in the ADC, but also happy to stick around for the end of the call and do this live. Gitter's great, but sometimes making sure we're all paying attention at the same time is handy.
Yeah, Gitter is not that good
Okay.
to actually take a decision and make sure everyone's on board with it, in my opinion.
Okay, then can we do end of the call, just stay after a little bit for the people who have been discussing this, or would that not be acceptable for some people's time constraints?
Sure.
I can stay.
Okay for me.
Yep.
Perfect. Okay, let's go ahead and do that and move on to the next thing. Let's see. I think the only other two things were Jason saying, suggesting that we might need to increase the cost of EXT code copy, and how to deal with contracts that break the increasing S-load cost, just like Aragon and others. Jason, do you want to comment on those? Or those things that would be like discussion topics for fixing in future hard forks, or something that we would need to talk about now?
I think we have to talk about the contracts that break now. The Xcode copy costs being off. We can talk about it. Almost all of these things are just me relaying random comments made in Gitter channels and issues that I'm watching. So I don't necessarily have any special knowledge about it other than what I wrote about. What I summarized already, which is that Xcode copy is now cheaper than a single S load. So it's sort of a start of a discussion.
Okay. Yeah, it seems like it could be important. Does anyone have a comment on that? The fact that the repricing. Go ahead, Martin.
Yeah, so to make an analogy, we're fixing a hole in the roof, and yeah, there's a smaller hole on the side. Just because we fixed the big one, we don't, we don't need to fix the second one in a panic. It's been there, it's going to be there. Let's fix it in due time if we have to. That's my comment about Xcode copy. It's nothing we need to fix for Istanbul, in my opinion.
Can I do a comment on this? Just like first of all, I think our position is always that I think we shouldn't do any dramatic change for any of the EIPs anymore, because our hard fork is already delayed, and we have some users expressing concerns, especially to us about why we are delaying the hard fork. So I think it might be better for Istanbul if we just go forward with what we have now and just don't change anything, so we can stay on the timeline and don't cause any delays. But what I really want to argue about is that we should really be careful about backward incompatible change in the future. There are two things I think people often miss. The first is related to like even like the issue with things like increasing ice load and cause some contracts to broke is not only that those contracts might be frozen, but actually for things like some contracts, like they may do time locked things or stuff. We also need to be really careful that it doesn't cause some users' money get lost, because like you can imagine, like previously before the hard fork, we can have some contract functioning normal and user can withdraw money for a period of time, but after the hard fork, the money is frozen, and this fund can expire and get withdrawn to another entity. This is something I think we should be careful about. And the second thing, what I want to argue about is the procedure that because the Ethereum community is growing bigger and bigger, and we have more parties submitting changes to the EIP for Ethereum hard forks. The issue is that any backward incompatible change can be used as an attack vector, because someone can try to deploy some contracts and then convince even some auditors, some users who use it. It works perfectly fine. And then after a year or later, they propose an EIP saying we are doing an in backward incompatible change. And if our core developers get convinced by them, the malicious entity might be able to cause some disrupt to the network, or cause those contracts that they previously deployed to be attacked, or to steal some money. So I think this is something we should be really careful about, and we probably should be improving our procedures in the future to make sure that we don't fall in those traps when we introduce backward incompatible change.
Yeah, I totally agree with what you said, Wei, most of it, I think. But I'm curious, a question for you. So what you said about not changing anything for Istanbul, was that a comment about...
sorry, can you repeat?
Blake? Yeah, you mentioned that it's too late to change anything at this point. Was that in relation to the proposed change to Blake?
I mean, we are fine if we change anything, but our position will always be we don't change anything, so we don't cause any delays for the Istanbul, because
right,
there are some users getting angry at us.
Yes, but what's your point, that you prefer we leave Blake intact, or what's your point not to throw in some extra?
So I think the nature like the like our position would be to leave the Blake2 ICs based on our position, but we are fine if we change that.
Okay, so there's a little bit of flexibility there, but otherwise we should err on the side of not making changes, especially like major changes to a lot of these EIPs, just to stay on schedule and to not have more delays than we already do, I think is how I read your commentary.
Yeah, right.
Okay. Thank you. Any other comments on what Wei just said? It seemed pretty straightforward to me, and I think a lot of us are on the same page.
I think that last time during the call, Wei raised a very important issue of 1984, and I while I totally agree that this change is very, very important to introduce for the reasons that Martin stated, I think Way has experiencing some pressure after the community started commenting on the parity delay. But as we see already, they merged everything and they're catching up very quickly. And it would be bad for party to just step back from those statements about security concerns. I think they're reasonable, and I think 184 can bring a lot of disruption if we don't address this problem with Aragon contracts and probably hundreds of other contracts.
Other comments?
Yeah. So I'm curious, Thomas, do you mean address right immediately, or do you mean that?
Yes, I think immediately for the reason that Wei stated that while we can think that just breaking contracts for a while, looking how it works, and then fixing it in the next fork or in the like some kind of emergency fix would be risky, because there can be some contracts that are time locked, which means that some users can lose access to their funds and then never be able to withdraw them after the fix comes, and they can be just locked out of the period when this might be the only time when they can withdraw the funds.
Have we run into any contracts publicly that is a case, or is this a speculation based on the fact that this is possible?
It sounds like a speculation.
Oh, Thomas, that was addressed to you if you have an answer.
Yeah, so I've seen the list that was prepared based on this the review that Martin organized with some team. Sorry, I don't remember the name of that team, but the list of contracts was very long, and beyond the time that we would have to analyze every single of them, how it exactly behaves. At least that's my feeling. Also, I don't think every single owner of those contracts is actually tracking how the change may affect them. So it is speculation, but I think that's very reasonable intuition that it might be difficult and dangerous. So I just wanted to discuss this like proposed change to 1884 that was suggesting this additional counter that treats the first 2,300 gas on stipend differently. I think it was in line what Alexei admitted, that it was in line slightly with his idea of splitting the limit counter and the gas counter. It's also analyzed the required change for the calculation for the actual client implementation. It seems to be non-invasive and simple, both on the like performance-wise, how it affects both the memory requirements and the computation requirements of the clients. So I would really like to discuss it more in detail, because I think not enough people read it and analyzed the suggestion. I believe it solves the problem without risks, because we taking using the fact that 9,000 gas is required for any value calls. So we're avoiding the attack vectors for leaving the S load being underpriced. And so we can raise the price of S load and at the same time secure, or for the time being, secure all the contracts that exist and not break them.
And to be clear, this would be something that would need to be prepared for Istanbul in order to be effective.
Yes, and I understand that this is what Wei mentioned, that maybe let's not change anything for Istanbul. But at the same time, last week Wei suggested that this is a reasonable concern about Istanbul 1884 change, and I agree to that. And I wouldn't like anyone to just withdraw now because of feeling pressure that we are delaying things. I think the backwards compatibility, well, sometimes it's unavoidable, but in the cases where we really see that we are like breaking the attacker's contracts, like you were mentioning about Tangerine Whistle, for this particular case, I think we have solution. We understand that there exist risks. The big contract creators like Aragon, I think, they raised concerns that is actually very, very problematic for them. That results would be very bad, and it may cause a lot of PR trouble, but also like undermine the trust in Ethereum as a platform and our ability to deliver the changes in a reasonable way.
Do we have any commentary on that? I think it's very valid concerns personally.
Yeah, so I think we're obviously kind of stuck between a rock and a hard place, and in my view, the proposal is kind of convoluted and complex and not properly analyzed. So I think that it's very optimistic to try to squeeze it in for Istanbul. And I also believe that if we postpone fixing it, we'll make a better job of it, and we can cover perhaps more cases than only. I mean, things can break for other reasons than default the stipend. And I think that, yeah, I'm just not sure if
I
that is the best solution. If we have time to find the best solution in Istanbul.
I think that so Thomas, a thought came to mind. If we make a commitment now to fix the contracts, including the timed lock contracts that would, make the ether unaccessible, then this is a commitment that we're making before anything breaks with the intention of fixing things that breaks, which I believe is different than, say, what, Wei was talking about before when it comes to having the perception that we're, you know, intervening in contracts necessarily. If we have this intention beforehand, then I think it's the similar thing to when we cleaned up the dust accounts. We intervened in that case for the sake of for states like, I guess, growth, and that wasn't really complained about very much. So I think with the right amount of PR about this, I think it would be okay.
So I personally yeah, I definitely think that if we break things, we should fix it afterwards. Yes, but I do think in all the cases where it's just, oh, it's hard, we need to upgrade to a new contract and it's a pain in the ass. I don't think that needs fixing. I just think they need to take that pain and go through with it, because they need to change the behavior of the contract, because the contracts exhibit some characteristics that we don't want to. We don't want, yeah, we want them to change the behavior. But there may be cases that legitimately are broken, and if it's the case that some ether is trapped for whatever reason, then I think, yeah, we should do something to fix that.
Just want to give a fair warning for the like this for the approach that we do a commitment and do a commitment to fix everything. The issue is we may end up in another EIP 99 situation. Because there may be some time lock contracts that are just designed that you
Yeah,
just
I would
can't withdraw
definitely
after a
agree.
fair period. So it might this commitment might not work. It might be controversial. So it might. It might be problematic. But I said our position is always we hope just we don't change anything, keep 1884 as is, and don't cause any delays.
I think consistent action will combat PR over time, because if we look back to how people thought about upgrade forks a year and a half ago, how everyone panicked all the time that we're going to have 2 Ethereums suddenly every time we were doing any of these, but now today no one's saying that. And I would say the reason is because consistent action has happened. That I think in this case, stuff like this is going to be happening more with ETH1X, and a commitment that if something's really like upgrading to behavior that isn't intended is of course the strategy entirely. But we're doing something, and we know we can do something to help fix that in the cases that it goes really wrong. Then as this happens more, and we have consistency in action and in plan and in narrative, that the PR will form around it.
What I was saying is that is not the PR aspect of this, but actually the technical aspect. So what I was saying is just that we, even if we make the commitment, we may not be able to fix some contracts unless we do something similar to EIP 999, which can be problematic for the community. So that is just what I want to give warning to the community, that we just may not be able to do this commitment.
Okay. The cat herders can write up something about this and pass it on to you before we publish it in order to make sure that we are correctly addressing both your concerns and your warning in a way that is palatable for people to read. I think, Thomas, I want to give you the last word on this, since you do have the option to make more of a formal suggestion within, within the EIP discussion, or an Ethereum Magicians thing, if you still feel really strongly about this. But it's seeming more and more like people do want to go ahead with Istanbul, despite the fact that it could break contracts, with the idea that we would fix them later. So I'd love to hear your last words on this.
Yeah, sure. So to sum up, the formal specification of what I suggested, I agree with Martin that it's not fully analyzed, and that's why I was inviting more people to analyze it. And I would love to see this analysis on a more detailed level. It is available on Ethereum Magicians, on the EIP discussion channel, on Gitter as well. So I posted it in the same form on all three channels. In the end, I actually, obviously, I trust Martin Way, the whole team, to actually analyze it. After I raise the concern, if everyone thinks that yes, this is the way to go, then I'll be totally happy to agree with that. I would still like to, in any discussion, for those concerns to be made clear, so people can react and discuss on them within the community. And I also agree with Wei that technically the solution to those contracts, potentially broken contracts, I agree that it's a speculation. It might be non-issue, or might be even worse. It would be if it was like just one or two contracts with something like half ETH or 2 ETH in them. Fixing them might be technically challenging, and it might require a lot of resources later. But in general, I totally trust Martin's analysis on the security and the general idea that asset change is super important. I agree with that as well. And because of that change being so important, we want to push, I guess, Istanbul as fast as we can. But yeah, I would prioritize the security and backwards compatibility, but I understand that in this case, security is what requires us to push the change.
Okay, very good last statements. I think that's very reasonable. Thank you for that. I think I want to quickly, if anyone has a really quick thing that they need to address that is very Istanbul related, otherwise I want to get to picking the block number so we could move on through the call. So is there any other comments that are necessary for Istanbul discussion before we talk about testnets and stuff? Okay. So we're talking today about picking the block number for the Istanbul testnet, which would then pick a number for the mainnet, because it would be about a month out from the testnet date. I wanted to start with EG. He's from the Infura team, who has dealt a lot over the years with a lot of these testnet deployments, mainnet deployments, and I know he had some perspectives and things he wanted to address here real quick, so that we can keep that in mind as we're doing this. So, EG, if you want to go ahead and just give a brief kind of what you told me privately, if you want.
Yeah, sure. Thanks, Hudson. Yeah, the main thing I wanted to bring up was that it seems like as we're coming closer to trying to set the block numbers for the fork, one of the lessons learned in the Byzantium fork last year was that we shouldn't try to set both of the testnet forks and the mainnet forks at the same time. Let's start with setting the testnet fork and see how that goes, and go through that typical finding that period of stability before revisiting when to set that mainnet fork, so we don't end up having to push it out. That's the main thing I wanted to highlight today.
Do we have any comments on that? I tend to agree that that is one conclusion that a lot of us came to last year in Byzantium.
I would plus one that, especially given that we're still discussing some sort of final issues around some of these EAPs. So it seems like, yes, we can get maybe a testnet block, but a mainnet block feels very early.
Are there downsides to not having them both at the same time in the client as far as exchanges and others preparing for upgradability and easing their concerns?
No, I don't think so. I think it makes sense.
Okay. Great. In that case, let's just do a testnet block, and we won't be picking a mainnet block. I know I have the word mainnet in the agenda, but we can leave that out. Since there are many clients who have merged everything, and just some of the things to iron out with Blake2 when should the testnet block happen? Should it be 1 week, 2 weeks, 3 weeks? What are we thinking?
So should we assume that we finalize the Blake changes today?
I think that is something. Matt, do you think that's something that is possible with working with Alex and others to do those finalizations today and merge the EIP?
Yeah,
Or James,
I
anybody?
don't see any problem with us coming to an agreement today. Piotr and I were just back channeling, and I think we feel pretty good about most of this. Just want to make sure that the rounds aren't completely fixed. But most of the other stuff discussed here, it's really about, do the clients, like, how much more fiddling do they want to do if we do change the EAP? But yeah, we're happy to play ball.
Yeah, it seems like Blake2 was the main thing left out in the end, or just the thing that needs to be like finalized before we merge the EAPs for sure, and cross-check from the clients how they're implementing it. Okay, so yeah, did that answer your question, Martin?
Yeah. So let's assume that all clients can release their next update somewhere next week, mid next week, late next week. And then how many weeks do people need to upgrade their nodes for the testnets? That's the question, I guess.
Does anyone have any thoughts on that for how long that takes based on past hard forks? In my opinion, I think giving because less people use the testnet than the mainnet, giving it a week and a half is probably fair, but that's just my first like throwing that out there.
Yeah, I would say 2 weeks would be preferred.
So that brings us basically a month from now, which is DevCon. So do we want to hard fork the testnets right before DevCon, at DevCon, or right after DevCon?
We can have the testnet run for more than a month if we want, so it's not literally smack dab in the middle of DevCon. That's not an issue. It's more when we want to start the testnet because I think that's the more
But
pressing
that's
thing.
that's what I mean. So if we have 2 weeks for clients to release an update, that brings you to like mid-September. If you have 2 weeks for people to upgrade, that brings you to early October. So it's like the week before DEF CON. Yeah, so just wanted to point that out.
I mean,
Oh, I see what you're
if
saying.
all clients can release their final client a week from now, Friday the 13th, then 2 weeks later will be 27th of September. It's still a margin before DevCon. We could do another week and we're in the 4th of October.
Yeah, in fact, it's usually preferable to aim for midweek, so doing it on the 2nd might be the best option. And by the way, aiming for midweek is because we don't want to do it on a weekend in case things go terribly wrong. Okay, so how does the 2nd sound for everybody? That brings us past DevCon for launching mainnet if we keep it up for a month. We can still have decisions made, especially if we want to do it even a little bit longer, if like we can't make a decision on the mainnet number because DevCon's going on or other things. We still have that opportunity to just have the testnet run longer and then have the mainnet block sometime mid-November.
That seems reasonable. I think there is value to forking the testnets before DEF CON because there's a lot of conversations that do happen at DEF CON. So that'll be like a nice way to, a nice opportunity, I guess. If we forked it right after DEF CON, it feels like a missed opportunity to share that with the community.
Great. Okay, so anybody else have comments on this or disagreements about having it on the 2nd?
There's one comment from me. Does it make sense to actually do a styling change on the testnet, starting with Rinkaby, which is practically only produced by Get, which means that we won't have consensus issues, at least at the beginning. Then very quickly following up with the Ropsten, which has two miners, practically two types of miners, Parity and Get, and then continue with Girly, which has 4 different clients actually creating blocks. So we decrease the chances of consensus issues and the testnet releases.
From the perspective of asking the testnets to do that, Ropsten and Gorley, we would have to talk to those teams, and I believe Peter's not here today because he's on a flight.
Yeah, you mean Rinkaby and Gorley.
Sorry, yep, Rinkaby and Gorley. So that would need to be a later discussion, but yeah, we could do those. We could definitely do those before this 3-week period, if as long as they agree to that. That would be something we'd have to talk about later, or have them on the next call, or things like that, though. But that's a good idea. Any other comments about it being on the 2nd for Ropsten? Okay, great. We're going to just do this on the 2nd then. That's what we're aiming for the block number. Again, for anyone listening in who doesn't understand how this works, we pick a block number that we estimate to be around the 2nd of November. However, that might be plus 1 or 2 days behind or forward from that date, based on a lot of like some of the factors of miners and how fast blocks are produced between now and then. So for anyone seeing like a headline saying it's on the 2nd, if it happens on the 1st or the 3rd or whatever, that's normal because of block times.
You mean 2nd of
All right.
October, right? Not 2nd of November?
Yeah, 2nd of October. That's important. I said November, didn't I? Thank you. All right. Yay, we did a testnet number. Okay. I want to move on to ProgPoW because we have the least authority team on today, and they released their audit report a few weeks ago, and unfortunately, uh, due in part to just people being busy and like just slipping our mind, we didn't release it in coordination with them until a few weeks later. So we released that report officially about midweek this week, and for people to look at. And I just wanted the least authority team to introduce themselves, who the people who are on the call, so that we can familiarize ourselves with that. If they want to give a quick description of their findings, that would also be nice. And then we'll provide any commentary that anybody has based on the document, any questions they have or concerns or ways that they can improve the document. And then in addition, if you're not comfortable giving feedback here, there is an email address that I posted in the Gitter chat and I can repost in there for everyone to send their commentary to. So we'll do intros, brief summary, and then questions, comments. Oh, and yeah, Liz, if you want to take this away.
Sure. Hey, it's Liz Steininger here from Least Authority. Yeah, thanks for the intro, Hudson. So the report findings, well, I'll finish the intros. I think also on the call we have Hind and Ram, and we also have, I think, Mirko and Jan, I think, watching the call too. Hind and Ram, are you there? You want to do a quick intro of yourselves?
Sure. My name is Hind. I'm a program manager at Least Authority and oversaw the project management along with Liz of the ProgPoW audit.
Hi, I'm Ram. I do security audits for Least Authority and also other security related stuff in Least Authority.
Is Kex part of your team?
Yes.
Yeah.
Hi, I'm Kex or Jan. I'm also doing security audits with Least Authority. Hi.
Yeah, and we also, I think Mirko, who is also in the project, I think he's watching along, but wasn't able to actually join. So yeah, if he has any comments, he'll just send us a message on Slack or something. So yeah, to summarize the findings, we have a nice summary also in the report that might be useful to just spread around too. And this is the initial report. Based on the feedback that we get, we've got some clarifications that we've gotten from you, Hudson, and Charles from the cat herders, and any other feedback that we get, we'll take that into account for the final report. So yeah, like Hudson said, feel free to email us any kinds of feedback for this, and we can incorporate it. So the summary here that we found that generally. Oh, yeah, I guess I see on the chat that somebody wants the email address. I think it's just progpow-audit@leastauthority.com, but somebody can copy in that text, or I'll do it when I'm done.
Yep, I can do that, definitely.
Thanks. And so yeah, so we found that it, on a high level, that it reaches its design goals, and that it's reasonable towards its intended economic effect, and no major issues there. But that said, we also we did find one particular attack that we outline in the report. We also found some, I guess I should say, potential attack, and I think that probably some others on our team can give more details if we want to get into more details on that now. And then we also had some just recommendations about things that could be done to have better, I guess, assurances of ProgPoW working as intended in the future. So things to look into and to assess. And one of the pieces of feedback that we did get is to clarify a little bit more what we might recommend that the community does moving forward after the switch to ProgPoW. And yeah, just basically things to do to help make sure it continues doing what it's supposed to be doing, I guess. But yeah, I think other thing to add on a high level is that also there's a lot of speculation, and I mean, we did a lot of research to try to like narrow down the speculation of what can happen in terms of hardware, and maybe not hardware, but like how this how ProgPoW could be overcome by like hardware advancements in the future. So I guess that's a high level. I do recommend it's much better articulated in our report. And I think I'll just let anybody else from the least authority team jump in and add anything that I might have left out. Or not.
Okay. So yeah, I can just like go through the suggestions from the document and just like say a word or two about it. Is that interesting to you?
Yeah, that'd be great.
Okay, cool. So the first suggestion was that like ProgPoW uses the modified catch-up function, like not the catch-up function itself is not modified, but use like a similar to the Blake2 situation where you have like parameters and actually it's round reduced as well. So it's like a slight modification. And it's not really clear whether or not this is like a proper hash function. However, it's used like while it's round reduced in the individually, it's used very often and chained. So probably there's not too much going on, which is why we say it achieves its intended design goals basically. But this is like a source of unclarity a little bit.
One question on that. Does that, when you say that it's not doing its padding at the end, is that the part that we're on? For the key chat function?
That is one part, but I understand that the padding should not be necessary because it's always the same size. But it's like it is a modification, and it would be nice to have people who like analyze hash functions day by day take a look at it.
Does the current etash do the same non-padding, or does the current etash do the entire padding?
As far as I know, it includes the padding.
Okay, thanks.
That's correct.
Okay. Suggestion 2 is address the light evaluation method. This is about the situation where you have like the stages where you first have the seed, then you compute the cache, then you compute the DAG, and in the DAG you just do lookups during the mining. And the cache nowadays is small enough, or is getting small enough, it's kind of unclear, to fit on an ASIC. Or like the ASICs grow or like you can put more and more SRAM on an ASIC, and it's either now or soon or something like this. It should be feasible to put enough SRAM on an ASIC to hold the entire cache, and then you can, with a little bit more computation effort, do the mining directly from the cache. But it means you don't have the memory bottleneck anymore, which is where the security is basically anchored of Ethash and ProgPoW, or like ProgPoW part. So this is something where it's not entirely sure like what the situation is right now. I'm not like a hardware expert. We talked to some people and like especially Bob, and it seems that it's either now possible or possible soon. And we got this information, like we verified this information from other sources as well. Is there any questions regarding this one?
So, quick clarification for those listening. Bob is Bob Rao. He is doing a very extensive hardware audit in addition to the least authority audit that focused on both hardware and software, but with a heavier lean towards software. And Kex, just to go over what you just said, did you say that although it met the goal, what I read from that is although it met the goal with increases in hardware like efficiency over time, like it might not be you might be able to get advancements through an ASIC that would be ProgPoW?
Oh, okay. Maybe to clarify, the same attack would work on Ethash.
Ah, got it. Okay, never mind.
So yeah, you just answered the first question that it also applies for Ethash. My second question is, so just want to see if I understand it correctly. The thing that would be needed is extremely fast memory directly on some kind of very fast bus, and not like DRAM, but some extremely fast thing that you can have faster access to. Is that the key to this issue, or?
So when you say, so the thing is that if you have the memory on die on the same chip, you don't need like a GDR bus or HBM or something. You just have it on your chip. You don't. So that's why you get like way better access timings. Access is much quicker, and because you need much less memory, you can put it on die now or soon, probably. Does that answer your question? So you don't have this bus that is currently slow all over the industry.
Yeah, it answers my question. What is not clear to me, since I'm also not a hardware expert, is this future technology? Is it now technology, or is it just very expensive? I mean, how? Yeah, it's hard to evaluate for me.
Yeah, this is for me. It's hard to evaluate.
So I've been looking over Bob's early audit. His should be coming out very, very soon. It's just in its final stages, and from my understanding, it's a lot about future hardware when it comes to that type of memory. And I might be reading the audit wrong, but I think Bob's audit's going to answer a lot more of those questions and speculations.
Yeah. So, to also add, I saw that I think Ram, you chatted this too. I don't know if you want to say it, but it's also this kind of memory is also more energy and efficient too.
Oh yes.
So, and then yeah. So I think that as far as whether or not it's available, like this kind of tech is available now, it sounds like it might be. But to get back to, again, I think maybe, yeah, Bob will help with that particular answer, but we did put a recommendation in for that suggestion too, about changing the constant data set parents to a higher value like 512. So yeah, there's that suggestion for now. But yeah, this is just another area to keep an eye on and to possibly discuss more, I guess. But I don't know, Cakes, if you have more to add.
Sorry, I have a question. And my question is, so these suggestions and recommendations, did you by any chance discuss them with the ProgPoW team and hear their thoughts about it?
No, we didn't. But the dataset parents, it means that the cache computation. No, sorry, never mind. No, we didn't.
Yeah, and this is something that if that would be a good thing to do, or yeah, if we wanted to do that, now is the good time to do it between the initial report and the final report, because we have these recommendations there, and we can you make minor edits to the report before the final one. But usually just clarification, nothing too fundamental in terms of changing the report. Did we want to go back to the other suggestions? There's a few more, but I think that those two are probably the most, I guess, in-depth ones. The other ones are more overall type comments, I guess you could say.
I just wanted to be clear. Is this something the existing ProgPoW can easily get past? Will it take a little bit more work, or does it look like a real problem for ProgPoW to get past?
Now, when you say get past, what do you mean by that, Greg?
To resist the attack. We knew going into this that we were in an arms race with the ASIC builders. So how does our armaments look?
So the proposition is to increase the constant dataset parents from 256 to 512. This constant describes like how much data has to be read for a data like for an item in the DAG to be computed. So this would make both the lightweight verification, where you don't have the entire DAG faster, slower, but also the mining. And I think increasing it should be sufficient for the following many years. So I think it's easy to find some solution. I can't really comment on how long, like whether it's 10 or 20 years, or 5 or 20 years. Yeah, I'm like whether or not this solution for how long it really holds. But there's leverage to tackle this, definitely.
Yeah, I mean, I think that our conclusion with this was that it doesn't mess up ProgPoW's ability to do its design. That if you change this to a higher value, that it should be okay.
Also, Ethash has the same problem again, so
yeah.
Yeah.
Thanks a lot.
Do we have any other commentary or questions for the least authority team before they move on to maybe their minor suggestions or wrap things up?
Okay. Okay. Do you want to do the last, or do you want me to?
I don't. You can go ahead.
Cool. I don't think it matters, but yeah. So the suggestion 3 was to create additional documentation. There's some key details that we thought were missing, and that improving the documentation would also just generally improve how people can help keep an eye on these potential issues in the future and stuff like that. So we called out a couple areas where there could be more documentation on it. Another suggestion is explore a formal model of ASIC resistance. And this is just something that, yeah, particularly if mining continues to be a growing industry, which it so far has been, but if it continues on that path, that just looking at this a little bit more formally would be helpful too. So yeah, just coming up with better security benchmarks for ASICs and formal models.
Can you define how you're using formally in this case?
It basically it doesn't mean it's not related to formal logic necessarily. It's more like yeah, like a sound mathematical model or something that you can actually reason about, because currently there's like, when it comes to ASIC resistance, it's mostly, yeah, it's just heuristics basically, and it would be nice to have something that's actually reliable. Yeah.
Okay. Are there any other commentary or questions?
Okay, then if not, then the last one is just monitor hardware industry advances. And while this sounds like kind of obvious in some ways, we just wanted to make sure that this got documented and call out some specific areas of hardware industry advances that we thought could be particularly a threat, I guess you could say, to ProgPoW in the future. And so we outline that in a little bit more detail. And also we wanted to talk about like the potential, the incentives of other parties and other hardware incentives I mean, other incentives for hardware to advance. So like outside of just, I guess outside of proof of work, mining and stuff like that. So that would be something that I think is also just good for the community and everybody to maybe have a way to keep an eye on moving forward. And of course, like this, like specialized hardware and stuff in the future of hardware is difficult for all of us to predict. But at the same time, you know, there's certain, like I said, certain signs and stuff that we're seeing and certain incentives that that to keep an eye out for. And so we just detailed this a little bit more in our last suggestion.
Okay, excellent. Thank you all so much, the team from Least Authority, for coming on and fielding these questions and providing an overview of their initial audit. If there isn't any other questions or comments on that, you all are free to depart, or if you want to stick around and hear a riveting conversation on Blake2B, that would also be okay. So thanks again, and let's go ahead and go back to the Blake2B conversation. We have about 4 minutes left of the meeting, so if people need to drop off at the now or once the official meeting time is over, that's perfectly fine. Otherwise, we're going to continue with Blake2B, and that should be the last thing on the agenda. Is there anything that I missed on the agenda that people want to address before we start on Blake2B? All right. So we still have Matt in here. We still have Alex in here. We still have a few other people, Martin. So who wants to tackle this? I know, actually, I think Matt might be best to start because you've been talking to your team.
Yeah, sure. Well, just real quick, we've been back channeling through, well, it's not really a back channel. We've been on GitHub and whatnot discussing this throughout the call. And I think where we are is we're not going to worry about the proposed change in T0 or T1. But Alex makes a great point. This is not really Blake2B specific, this EIP anymore. Unfortunately, you know, the RFC doesn't quite have a target that specifies exactly what we're trying to do with this EIP. So I think the discussion that we need to have here to sort of close the loop and perhaps even be done talking about this EIP is, do we want to revise the EIP, make it clear that that this is for all Blake2 64-bit variants, and then also we're fine with limiting the rounds, which has been another thing we've been discussing back and forth. I just want it to be more flexible than fixing it to 10 or 12 because there's some sort of exotic stuff our team and a few other teams that I've talked to have considered that would limit. So anyway, my stance is typically I don't always know what an application developer is going to do with something I'm building. And if it's not an attack on the EVM, and if it's not dangerous and it's already well tested, we should give them more flexibility.
When you're talking about these exotic things, what's the kind of order of magnitude of the number of rounds you're talking about?
Yeah, so actually for the stuff, for anything that I've been looking at, I would be fine with just a single byte's worth of rounds. I think that, as Alex rightly pointed out, the 32-bit round was totally plucked out of air. So I don't think that is the right number. I know that it is more than 12, and I would say less than 10,000. But if it were limited to a single byte, we'd be okay. Obviously, that's a really wide range of numbers, but.
Are there any references to these experiments anywhere? Because I couldn't really find such configurations.
Yeah, sure. So the reduced, and again, the only reference we've given you that's public is the one from Zuko. So I think the reduced round is pretty clear for a future hash variant. But no, this is all stuff that we've been discussing internally or in person with folks. Alex, and I'm sorry I don't have anything better written up for you. I think that we have some authority to lean on here, that it would be reasonable to go below 10. And yeah, I mean, I guess I'd like an argument as to why we wouldn't want to allow above 12.
I think we wouldn't have had any of this discussion if from the outset it would have been titled that this is, as you suggested today, that this is a 64-bit flexible Blake2 compression function, because then it would have been more clear. Because I've been confused and
that's fair.
I've seen implementers
we should have caught
be
that
confused.
much earlier. You're totally right. So I guess what I'm wondering is I'm comfortable going through and revamping the EIP to make sure that it more accurately represents. I think what a few people are trying to do here. That doesn't answer the question of what is a reasonable round limit. So I think part of what I'm wondering about is what we want to ask implementers to do, considering the Istanbul schedule. I think our team would be fine dropping it to 16 or 8-bit for the rounds, and we would not have any problems. And I think that I can turn around the EIP in the next 2 days in a way that's much more accurate and covers the fact that this handles other Blake2 variants.
So I have a question for Alex. So from an implementation perspective of where you verify the Zcash stuff, what gas-wise difference would it be to drop the rounds versus having a 1 byte for the rounds?
Oh, there's no difference for that. It's just hard-coded in my case. But the implication is on the implementer side, because if this is clearly a Blake2B compression function, then they likely can use off-the-shelf software and libraries.
Yeah.
But if this has the rounds, then they cannot. They have to implement it themselves, duplicate some code, make the changes. And I think that's where people were really confused, because when they reached out to libraries, well, of course, they realized they cannot use libraries first of all. So they reached out to them and asked for this compression function. And whoever has implemented Blake2 was really confused that you want the rounds, but you don't specify the rest of the configuration.
Absolutely, and we had to do that for the Geth implementation as well. We had to rip out the Go crypto function because they didn't export it at all.
Right, and then Peter had to rip out again to get the assembly implementation. So quite a lot of work has gone into it already. So in one sense, I think this would have been made more sense to discuss a couple of months ago. But at this point, I think, hasn't everyone already done this?
So I have not, if that counts.
Yeah.
And I mean, it's not a blank check, but we are here to help. We have an interest in getting this through as well.
Yeah, for me, it doesn't really matter. But what is important, I think, is it would be really good if we decided to set it in stone today so we can just ship it.
So I think the only reason it could make sense to set a lower bound on the rounds is to avoid any risk with the gas usage, where maybe somehow, you know, the 1 gas per round, which was determined, somehow with large rounds, it could not be accurate. That could be one motivation to set a lower limit.
I think to be clear here, we performed benchmarks both on large rounds and on small rounds, like 1 round computation, 2 rounds computation. So it all fits together in terms of the gas price.
I think it sounds like there may be some motivations to keep the rounds at this point, maybe, but decrease the size of it. What would you say about that, Axel?
I mean, since it has been implemented, and if there's a real reason that there are going to be other configurations of 64-bit Blake2 with different rounds, then maybe it makes sense. But yeah, as I said, we wouldn't have had this discussion if this would have been clear from the beginning. From the user's perspective, the rounds doesn't really matter. It can be hard-coded. This is really only a question for testing and client implementation.
Which, since those have already been done, I think it would make sense to update the EIP language, because that doesn't do anything to the hard fork or the implementation schedule.
Well,
yeah, I think the EIP has to be clarified. That's for sure.
And we had, when we first talked about Blake2B, we had asked Zuko and others, is Blake2B the only one, or is Blake2 what's important? And then we went into, well, if that's the only thing that matters, then really it's the compression F function, which we can get from somewhere else and just plug that in. And then rather than us do a Solidity implementation now, which would be much more resource intensive, we can get the compression function done, and then we can release best practices or libraries that interface with the F function. So I think this is a little bit of the EIP hasn't followed, like the writing in the EIP hasn't followed the evolution of the discussion that has happened with the community.
But is there any practical use case for other number than 12 at this point?
Yes, absolutely. So if you're talking about any additional hash configurations that are put together for example, Internet of Things applications, and we need to verify that, then this will be forward compatible. If you're talking about proof of work tweaks, like what we just saw with SIA, not to be clear, they didn't change the rounds, but a similar idea to break ASICs that we need to verify, this will be forward compatible. So there are definitely, there are definitely reasons. I understand that it's more difficult to defend potential future development from app developers than it is to point to a spec that needs it.
I mean, my main concern is this is like semi-flexible, because you only have the rounds which is flexible, right. And pretty much every other.
Yeah.
Sorry.
No, I was just gonna say I do wish we had gotten Blake2S in there. I agree that if it were properly flexible for non-64-bit systems, that would have been great.
Well, ideally, it would be completely flexible, and it would require a couple of more fields. But probably it's too late to change that.
I don't see why we couldn't in a future hard fork, but yes, I do think that for this precompile, that would be quite a lift considering our timeline.
Well, you cannot change the precompile once it's deployed.
No, I know. I just mean, obviously, that's too much of a lift before Istanbul. If we thought that there was something worth doing in the future, I think that's a question more for you guys who have a better feel for how the EVM is evolving than for our team.
For what is worth, one comment: if you want to have 32 bytes optimized version, it probably means you need a separate precompile. Having it in one precompile would be horrible in terms of developing against this precompile, because I know we have like 2 or 3 additional parameters that contain some bytes, so it's not really developer friendly to have it in one precompile.
So from like pragmatic perspective, like I think many people are annoyed by precompiles in general, as it's difficult to get them in. And if you're saying now like there's a chance we'll have another Blake2 precompile in 1 year, I think that might be even more resistance to that.
I agree. I do not think that I expect. Look, I just don't want to speak to how WASM is going and whatnot. I don't think that it's.
I'm just saying it might be the only chance to get it in. So if you think it's not ideal, I think it will be like that. That would be the outcome I would bet on. So if it's wrong, it will be wrong. But to get another chance to introduce the fixed one, I think it's less likely.
That's fair. I mean, I expect, considering the work that EVM1 team has done and whatnot, I expect that a lot of these problems will go away. Our team has no need for Blake2 or for 32-bit or below variants. But I can only speak for our team. I'm not every other team that's ever used Blake2. But we haven't found a strong Blake2 interop reason either. And so I'm not, I mean, in the same way, right? Like maybe in the future, there is a reason that someone starts doing 32-bit focused hashes, but we haven't found one.
Okay, so what is the decision?
Just to be clear, we're happy to drop down the rounds limit to 16-bit if that makes folks more comfortable around abuse. And I'm also, either way, the EIP is going to get a bit of a rewrite to make it more accurate to what it's actually doing. So that's where I am. And obviously, we can be flexible if you guys land somewhere else.
So I'd propose dropping the rounds down from 4 bytes to 2 bytes.
Axix?
So I've been Googling just to find any kind of reference to people trying a Blake2B with different rounds. And yeah, I have been unsuccessful finding anything. I mean, ideally, since, yeah, I mean, Blake2 has been around for a while and there hasn't been any such use. So ideally, I would go with just a proper Blake2B precompile and then maybe introducing a fully flexible one. But I don't think we have that chance at hand. So I would be okay with keeping the rounds parameter, and I don't really have a good answer what size that should be, because it's really up to people who understand hashing functions more deeply to know what rounds would be appropriate. One thing I have found is a comparison that 4 rounds of Blake2 would be equivalent of 8 rounds of Cha-Cha in complexity. So probably going below 4 wouldn't be useful, but I haven't found any kind of upper bound. So I'm not sure what's the right answer to that.
I think someone mentioned an argument for 1 byte where we avoid endiness issue.
Yes, and I see only reference to 10 or 12 rounds for Blake2 in general. So why do we need 2 bytes?
That was the recommendation for Zuko was to do to go up to 10 or 12. My memory is correct, and also with James. And I think it's a bit of like, if I was to try to figure out what's going on with EVM1 like right now and what you guys are working on versus like what's publicly available about it, there's just like the information isn't all out there because the teams that are working on it are pushing out things as they're happening, but they're not pushing out things that they're thinking about happening until they've happened, because that's just not a really good practice. So if the people who are working on it right now, who are say, hey, we see reasons for doing 10 or 12, and the hard part of doing the work of getting the F function out has already been done by the implementers, because that's who's really the work is added on is for these
the work has already been done that's been added on, then I don't, and we've also verified that there isn't a gas problem with having higher rounds because that's already been benchmarked. When people were looking at it, I don't think like necessarily limiting it to, oh, we couldn't find it on Google, so then there is no people working on this, is like the right way to go. When we've heard from people who are working on it, that 10 or 12 is what they've been looking at.
Well, we know that if you can't find it on Google, it does not exist. So if I'm hearing this, if we just go with what's been implemented and tested, clean up the EIP so it describes what's been implemented and tested, we can just go with this and stop arguing about the rounds, because you can set it at the Blake2B number, wrap the necessary EVM code around this to implement Blake2B, and everyone's happy. Did I miss anything?
So actually, there's one more thing I forgot to mention is the Sigma table, which is only defined for 10 and 12 rounds, and the RFC suggests to mod 10 the rounds when looking into the Sigma table, but some implementations don't do that. So I wonder, you know, for a higher number of rounds, would the configuration need a different Sigma table?
Alex, so there are test cases that do more rounds than 10 or 12. So as far as I can tell, the implementations agree on what to do about it, but I don't know if it's specified.
There in the RFC, there's a question about how to compute sigma, from what I remember, and all those rounds should be based on the same sigma values. So I think it's not a problem.
Well, the Sigma itself is hard coded. It only has 12 entries.
Yes, but those hard-coded values can be evaluated from the equation. So the equation is takes, as far as I remember, the index as an input. So I need to check, but
well, in any case, I think the EIP has to be greatly updated to include all these details. I don't think it can just refer to the RFC.
Agreed. So if you guys don't mind, either way, I'm going to put together a checklist of what we agree in this call in this in the call thread. In particular, I'll try to be specific about EIP changes, and I'll have a PR in the next couple days.
Yeah, a closing note on this round stuff. I think the reason it's really confusing because the EIP just refers to the RFC, and the RFC doesn't make the round configurable. And therefore, I think we're not implementing the RFC here. We're implementing a very specific version of Blake2. And maybe it would make sense to make this clear that we are not implementing Blake2B or Blake2. We are implementing a really specific version of Blake2.
Or maybe a really specific superset of Blake2B.
Well, it's a subset of Blake2, maybe a superset of Blake2B.
Right. Yeah, I'm happy, and I'll put that language together and put it past you, Axik. I imagine we can come up with something we're all happy with.
And I really hope that configurations using different rounds going to be released, because otherwise it seems that this feature was added for no reason.
Did we come to consensus on the size of rounds? Carver, you wrote.
Didn't y'all say 12 or?
No, the side. I mean the bit side.
Oh.
It's either leave it how it is or stick with 2 bytes. I don't think there's a strong stance for 1 byte, though. If you guys want it, that's fine.
The work has already been done, and the only thing that needs to be updated is the language in the EIP. Then we might as well leave it as it is and have testing exist. The testing and implementation are already done.
I would say decisions shouldn't be made based on work has been done or not until we have the chance to make things right.
If the reasoning is to save us from doing work that has already been done, then I would disagree with that. But if it was because we've done work, then we should keep it. But if the rationale is that these changes would save us from doing work, but then that work has already been done, then I don't think that is specifically a case to undo.
I'm not sure. I don't think we are discussing any kind of changes just to save time. We are discussing changes to make a good precompile. At least that's my motivation.
I mean, obviously, this precompile is going to be around a long time, and we want it to be robust. I think the trade-off is if we make a significant change in the signature, that means that we are going to be more rushed and more likely to make mistakes, and people will do rework. So I do not know enough about the ETH development process to know which is the safer choice, but I do think that there is a safety concern aside from is this the best possible signature, and I think that's will all of these teams implement this well. But again, either way.
Yeah, I do like the proposal from Martin to have EIP oriented hard forks because we wouldn't run into this problem what we are in.
Yeah, that's certainly going to change, is my expectation.
I'm planning on following up on Gitter with kind of a large, like our experience with the EIP process so far in case it's helpful for you guys. But I think the flip side is if there weren't a fixed hard fork, maybe this wouldn't have been considered important enough to include in a hard fork. So I think EIP specific hard forks are going to be awesome. But for teams like ours that aren't solely focused on pushing Ethereum forward, but we do want to help, that has been the benefit of a fixed schedule.
That's good feedback. I would love to see a complete feedback from you. That would help me tremendously as I'm kind of coordinating, helping the process improve as we get a hard fork coordinator.
I'll get you a full write-up, if not a blog post, at least some thoughts on Gitter, because we did also try to get into the last hard fork with 1108 and learned a lot about kind of how the process has evolved.
So,
great. Don't hold back any commentary. Go ahead, Martin.
Yeah, I was going to say, so Carver sounded like he was for changing it to 2 bytes. I don't really care. Anyone else?
So that would change the size from 213 to 211?
Yes.
Seems reasonable.
From a testing perspective, it would be kind of easy to adapt the tests and just regenerate.
Trivial.
Yeah, I'm not sure what is an upper bound for the rounds. For all we know, it could be even bigger than 32-bit. So I'm not sure how to make a decision what is a reasonable number.
But that gets us into like millions of rounds, doesn't it? No,
yeah,
no,
eventually.
16 only gets us to 64,000. The thing is, with the rounds beyond 8 million, we'll have to. No, okay, like it won't go beyond 8 million because blocks are limited at this amount of gas. But we would need more than 2 bytes to get up to 8 million. Yes, we need more than 2 bytes, but it's up to you. I mean, like we'll go with whatever we decide here, whether it's 1 byte or 2 bytes. The tests are maybe a bit more cumbersome with because we have to think about the edge cases, like how it behaves with different Sigma module that Alex mentioned. So
we have to pick the good range of various test cases with different numbers of rounds. So the bigger the number, the more we have to test, but in the end, we can test it, obviously.
Yeah, I really hope there will be a variant released after the hard fork, or maybe before, which makes use of a different round.
We do plan to share our work. It's just early.
So does anyone feel strongly about changing it?
So I guess I'll give some more background on why I'm also in favor of dropping the number of rounds. Is the you know, we've got at least currently an unoptimized implementation, which is you know, if we dropped the number down to 2 bytes, we could probably leave it as is, unoptimized, and not worry about it, because the cost of calling the precompile makes up for the fact that 1 gas isn't enough to account for the time it takes to do 1 round in Python. Now, you know, obviously we shouldn't make a decision based on this particular unoptimized implementation, but if it makes it easier for other clients to do a simple implementation quickly, then maybe there's some value there as well.
Okay. I've been trying to follow this, but I don't know what the next step is. Can someone pick up on that?
16 bits or 32 bits, and we need the decision soon in case client implementations need a tweak. And as champions, we do not care as long as it's one of those 2 and not fixed to 12.
Can I just pick?
Yep. There's been mostly I don't really care from everyone.
I like the number 32 better.
32 is already implemented and tested and written is the strongest argument for 32.
Oh, let's do that then. All right, 32 it is. Or Martin, did you have a comment that I interrupted you on?
No, I wanted to see what Axix thought about it.
Yeah.
Alex, did you have a comment?
Yeah, I'm really not sure. It seems that technically the upper bound we have is just 8 million rounds, because that's the block gas limit, right. Or maybe 10 million rounds, which you couldn't address in 16-bit. But yeah, we are yet to see any kind of configuration which goes above 12. Because one of the main benefits the Blake2 specification cites compared to Blake is the lower number of rounds. So I would assume that they would only just marginally go above or below the standard. I don't really see how they would go anywhere close to 8 million.
I agree. Nothing that we've. Yeah, I mean, that's why if we went down to 1 byte, it wouldn't bother me. It's just that, again, I don't know what other teams are working on. Which is why I think 16 is fine. I think the question really is it more helpful to help like Python and other unoptimized implementations, or is it more helpful for no one to have to make any further changes other than rationale and history in the EIP? Rationale, history, naming, all of the EIP, but nothing around the code.
Sorry, I actually got to leave the call now.
Oh, thanks for sticking around, Martin. So it sounds like 32?
Fine by me.
Test case is already 32. Any other comments on that?
Well, there was the other proposal, the message length parameter. I guess we don't really have time to, or do we?
I mean, some people are sticking around. It's I almost said my local time, but can we just have someone make a suggestion on Getter if that's the last thing?
I mean, are the champions against it, or is anybody against it?
Yeah, or you don't have a problem, do you?
I mean, from my perspective, it's a question whether we want to stick to the RFC and add the parameter about the rounds, or do you don't want to stick to the RFC?
Well, I don't think we're sticking to the RFC anymore because we have the rounds.
Oh yeah, that's fair, but it's one change. I don't know. I don't really have a strong opinion here. From the perspective of the implementation, it's easy to change. At least I can speak for Get client, but I can speak for other clients. I guess it's harder. For sure, it's harder than changing the size of rounds.
So the motivation is I've implemented I think, more efficient implementation of using the precompile on the EVM. And the key optimization is to keep the context once in memory and keep reusing it. And in that case, for the last chunk, there's a need to zero out the memory in the context. And it seems to be, I mean, it seems to be an easy way to avoid that. And in the case of the Zcash proof of work, there are 512 rounds.
I mean, if there's opposition to doing a very trivial change like dropping a number of bytes of rounds, I'm pretty sure there's going to be more on this other change that would require a lot more testing vectors.
I don't know. From my perspective, as far as the implementation in Get is concerned, it's not that easy to change. I mean, it's easy to change. Sorry. I don't know what are the other use cases for F. Maybe they will require more. I don't know. It's like the question about maybe leaving the freedom to developers that are going to use this precompile. Is there a very large difference between the gas cost of calling the current version and the version that you're, Alex, proposing?
Well, it's an extra 1 byte, so that's the only difference in the cost. But preparing the message is cheaper on the EVM if you don't need to zero out stuff.
So this difference hits once every precompile call, just to be clear. Because it's just the message prep.
I don't know. I don't have a strong opinion here, to be honest.
I'm happy to be we should stick with what we already have guy, because I think that's typically pragmatic. And because I don't think that people are going to be calling this precompile in a hot loop, so we're not going to be doing the message prep frequently. So I'm happy to take up that side if we need that on this call. But yeah, it's not going to be a huge difference to us.
But if they're not preparing the message, then how are they going to call the precompile?
Oh no! I just meant this is not. How many times are you going to prepare? You know, like in use cases, we're looking at how often. Yeah, I mean, just this is kind of going back to your own argument. How expensive is this actually going to be verifying Equihash?
Well, you need to prepare a message for every 128 byte chunk of the input. So I'm like a tiny bit confused when you say that this isn't going to be used frequently. That would mean that people won't be using the precompile.
No, I'm asking if you have an idea of how big. I mean, this is what Piotr's comment. If you know how big the difference is going to be, so we could actually like assess the damage.
It sounds like a 20 gas for me, like for every single call of 128 bytes, as Alex says, because you need to clear 128 bytes of memory. So you have to load to memory, and I think those will be free for every single write, or is it more, Alex? I think it might be even 40 bytes.
Yeah, I mean, you would have to clear it. So if you're sending the last chunk is only 1 byte, you have to clear 127 bytes of the memory.
Yeah, so these are 4 M stores, right?
That's pretty
a single M store is 6, I think. So it will be 24 gas plus some logic around it and looping. So like maybe 40 gas for every 128 bits.
So the bigger problem isn't actually just zeroing out that memory. That isn't that expensive. But if you have a loop where you have an input memory and you are splitting it up, if you have to support the current way, then you have to have a lot of different conditions. How big is the input? Or you could just zero out everything prior and then overwrite it, or you could just copy the right amount and then zero out the remainder. So it becomes way more complex as compared to just being able to set the length.
Well, I mean, you guys are obviously the EVM optimization experts, not our team. And as long as it's not restricting the functionality of F, if it's cheaper by 20 or 40 gas per invocation, that seems worthwhile.
I think we're starting to burn out.
Yep.
Is this the last thing to decide?
Yep. Yeah, this was the only remaining question.
Let's move it to Getter once we've had a little bit of rest. Anyone agree?
As long as you're fine with that, Matt, I can help keep the conversation moving on both sides.
Yeah, I just want to make sure we resolve this quickly. Again, we don't have nearly as strong a stance on this, so if you guys are happy and we're okay with the implementers, the client team's dealing with this. But yeah, let's follow up on Getter.
Okay, thanks so much, James, for pushing it on both sides, and thanks everybody for staying over. We will end this now. Thanks everyone.
Hudson, just to be clear, the next call will be in 2 weeks, right? Because one was off schedule, I think, or we pushed it back a week or something like that.
Yeah, in 2 weeks from now will be the next call.
Okay, great.
All right, bye everyone.
Cheers. Thank you. Bye-bye.
Bye.